that little activity that we just did, when we did investigating the triangle, then we investigated the quadrilateral, then the pentagon, then the hexagon, that's all Theorem 11.1. And it says, Theorem 11.1 is called the interior angles. So what does the word interior mean? Inside, yeah. Interior is the word that means inside. So this is called the interior angles theorem for polygons. So it says the sum of the measure of the angles of a convex polygon. So what does convex mean? Yes, not concave, yes. But what does the word convex mean? All sides go on the exterior, right? If you extend the sides of the polygon, they stay on the outside. They never go inside, right? So if you have all sides of a convex polygon, the interior, the sum of the interior is going to be n minus 2 times 180, where n is representative of your n-gon. So we just figured that out on that little activity that we did in investigating the triangle, and then we broke that up into went up to the quadrilateral, then the hexagon, and then the pentagon. So the sum of the interior angles, this is equal to the sum of the interior angles of a convex polygon, n minus 2 times 180. So the one we did in our head was a side that has 102, a figure that has 102 sides is going to be 102 minus 2 is 100 times 180 is 18, what did I say, 1800? There we go. Or 18,000, whatever it was. I forgot the example that we said. All right, now, let's do an example together. Take your ruler, give yourself this pentagon-looking figure. So how many sides does the pentagon have? 5 sides, very good. So we have a pentagon. Pentagon has 5 sides total. And we know a little bit of information about the pentagon. We know this is 114 degrees. We know this is 145 degrees, or sorry, 105 degrees, excuse me. We know this is 102 degrees. Every day, same thing. 135 degrees, and then x degrees. So it's going to want us to solve for x. So we have a pentagon. So the question is, what is the sum of the interior angles for a polygon, for a pentagon? So that's the question, right? What's the sum of all of the interior angles for a pentagon? Yeah, we know it's 540, right? Because we did this. Well, we took 5 minus 2, and then we multiplied by 180, so we have a grand total of 3 times 180, which gives us 540 total degrees inside that pentagon. Because the theorem right here just told us that that's what we did, right? We took 5 minus 2 times 180. So we know there's a grand total of 540. So the question is, how much has already been used? Well, yeah, we'll just take 540 and start subtracting. Let's subtract 114, and then we'll subtract off 105, and then we'll subtract off 102, and then we'll subtract off 135. And whatever's left over has to be the x part. Okay, so if you have a calculator. Okay, where are we at here? Jared, what'd you get, buddy? 84. Can somebody else verify that Jared's right with 84? All right, so we have a missing angle of 84 degrees, right? 84 degrees. Okay. Let's move on to the corollary. Okay. Let's move on to the corollary here. Okay. This is corollary, a corollary to a theorem, as we learned like way back in the first couple of months. Corollary to a theorem is a theorem that goes with the other theorem that we have. So this one has to do with regular polygons. So we have to remember what does the word regular meaning when it's describing a polygon. Does anybody remember what the term regular means? Mr. Hatcher, what do you think, buddy? There you go. You got it. Regular means equal sides and equal, I think you said angles, right? Okay, equal sides and equal angles. So regular means equal sides and equal angles. So like an equilateral triangle is regular because all the sides are the same and all angles are 60 degrees. So a corollary to our theorem says the measure of each interior angle of a regular polygon is the following. Is n minus 2 times 180 all divided by Rn. So that is important, and remember it must be regular in order for that to work. And regular means equal sides and equal angles. So this is a corollary to theorem 11.1. It says the measure of each interior angle of a regular n-gon is n minus 2 times 180 over n. So you just divide by the n. Here's what it says. The question is this. If you know the measure of each angle of a regular polygon is 140 degrees, how many sides does it have? Okay, I'd like you to try and solve it on your own. You don't have to write the question now, but you have to try and solve it on your own. Okay, the question's asking us the measure of each angle of a regular polygon is 140 degrees. How many sides does it have? Well, the number of sides will be n. So we're going to have n minus 2 times 180, all divided by n has to be 140. Because it's telling us that each measure is 140 on the inside. And it's telling us that it is regular. So I can use the corollary. So I use the corollary. Okay, so this tells me that n minus 2 times 180 has to equal 140n. I multiply both sides by n. So that means distributive property, 180n minus 360 equals 140n. You with me now? So negative 360 equals 140 take away 180 is negative 40. And divide by negative 40. And we have our answer. N must be 9. 360 divided by 40 is 9. Who got it right? Let the record show there are 4 hands in the air.